Hi everyone, in this video we are going to discuss about the basic operations and manipulations done on discrete time signals. So we are going to assume a signal, discrete time signal with x of n with some defined samples. With the help of this x of n, we are going to see the properties related to this discrete time signals like advanced properties or advancement and shifting property, compression property, right? These are the major and basic properties done on discrete time signals while solving the problems, right? So to start with, let us assume a discrete time signal x of n with the value x of n is equal to, the samples are 1, -1, 3, 0, 2, 1 and 1. So these are my values and my sample starts at this position, right? So starts at this position means n is equal to 0. So this is the 0th sample magnitude or amplitude, right? Now, so the signal will start from n is equal to -2, -1, then 1, 2, 3, 4, right? These are the discrete values, sample values, right? So I need to find first, number 1, x of n. So I'm going to draw the value for x of n for the given sample. This is represented as n because this is a discrete time signal, so we cannot write here it as t because t is for continuous time signal. If it is discrete, I need to represent the signal by n, small n. So it starts from -2, -1, 0, 1, 2, 3, 4 and 5. These are all my sample numbers, discrete sample numbers, right? So for n is equal to 0, the amplitude is 3 here. So n is equal to 0, the amplitude is 3. N is equal to -1, the magnitude is -1. For n is equal to -1, it is -1. And for n is equal to -2, the value is 1. So positive 1. So 1, right? Similarly, for n is equal to 1, it is 0. N is equal to 0. For n is equal to 2, it is 2. N is equal to it is 2. And for n is equal to 3, it is 1. And for n is equal to 4, it is 1. Right? So these are all my given samples, x of n. This is my x of n. With the help of this reference signal x of n, I am going to find the next sample, that is, let me draw it here. My second signal is x of -n, right? So I need to find the value for x of -n. So let me draw a line with n samples. So -n means it is a time reversal. It is a time reversal of x of n, right? So I have already a signal for x of n. I am going to reverse this corresponding signal to get x of -n. Means the right side terms will shift towards left and the left side terms will shift towards right, keeping 0 as the reference sample, right? So it will start from -4 because in here I have 4 plus 4, so the -n is an opposite to plus x of n. So -4 minus 3, minus 2, minus 1, 0, 1, and it ends with minus 2. So here it will ends with plus 2, 3, 4, etc. Right? So 4 man it is 1, and for 3 it is 1, 1. Next for 2 it is 2. Next for 1 if it is shifted there, then it will be at minus 1, right? So for this it will be 1. Next for 0 it will be 3, is 3. Next for minus 1 it is shifted to right side. The left side signal will be shifted to right side. So minus 1th sample will be shifted to plus 1 sample. So minus 1, and for minus 2th sample will be shifted to right side. That is, I'll have one, right? So this is my x of minus n sample, right? Now let me go for the next operation. We have performed two operations here. One is x of plus n, next x of minus n. Now let me go for the third operation, that is x of n minus 2. So before that, let me write the value for x of n in the slide. So x of n is equal to 1, minus 1, 3, 0, 2, 1, 1, where 3 is the 0th sample, n is equal to 0, right? So now I am going to write or perform the operation for x of n minus 2. This corresponding signal is nothing but I need to add a 2-unit delay for the given signal x of n. I already have the signal x of n with me. Let me draw the signal once again here. So x of n can be drawn. So minus 2, minus 1, 0, 1, 2, 3, 4, 5 is n. So minus 2, 1, and for minus 1 it is minus 1, and for 0 it is 3, and for 1 it is 0, and for 2 it is 2, and for 3 and 4 its value is 1, right? This is the value for x of n. Now x of n minus 2 means I am going to add a delay of 2 units. Minus 2 means 2 units. If it is minus 3, then I need to add a delay of 3 units, right? If it is 1, then I need to add a delay of 1 unit, right? Delay in sense, I am going to shift the signal x of n by 2 units right side, right? This is going to be done. Now look at here. So this is my discrete signal axis. Now each signal will be shifted 2 units, means the minus 2 will come to 0th place, and minus 1th sample will move to the first plus 1th sample, and 0th sample will move towards right side. I mean to move 0 to 2 and 1 to 3, like this it will be moved, right? So the signal will start from 0, right? Let me start from 1, minus 1, 0, 1, 2, 3, 4, 5, 6, etc. Right? So minus 2, I'm going to add a delay of minus 2, so it will be shifted 2 positions right side. So minus 2 will, so sample value will be replaced in 0th sample. So 0th sample will have the value of 1 year, right? So minus 1th sample will be at this first position, first sample position. So I will have minus 1 year, then 2 will have the value of 3, and 3 will have the value of 0. This 1 will be shifted to here, this sample, so 0. Next 2, 4th sample will have 2 here, 2, and 5, 6 will have 3 and 4. 4th sample values 5 and 6 value is amplitude value is 1 year, right? So this is my x of n minus 2, right? So let me solve another operation that is for x of 3 minus n, right? So x of n is equal to small x of n is equal to 1 comma minus 1 comma 3 comma 0 comma 2 comma 1 comma 1. This is my n is equal to 0th sample row. So now I am going to perform an operation x of 3 minus n. 3 minus n operation can be performed with the help of two operations. The first operation is time advance, and the next operation is time reversal, right? So to perform this, I already have the signal x of n. Let me draw the signal x of n, or let us see the x of n here. So this is the x of n. With the help of this x of n, I am going to advance it by 3 units to get an x of n plus 3. I am going to advance this x of n signal by 3 units. Advance means I am going to add 3 samples in left side of the signal, right? Now this corresponding signal can be written as this is n. It will start from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, right, etc., etc. Now my x of n start at minus 2. If it is advanced by 3 positions, advanced means I am going to advance it by 3 units to get x of n plus 3, right? So I am going to advance it by 3 units. So my x of n is starting from minus 2. If I advance it, then 3 positions prior to it, so it will start from minus 5th sample. So 1 for minus 5, and minus 4th sample will get minus 1, and for minus 3 it will be 3, and for 2 it will be 0, 1 year, right? And for minus 1 it will be 2, and for 0 and 1 it will be 1, right? So I have just shifted this each sample 3 positions left side, right, to get x of n plus 3. That is this sample, right? Now the first step or the first operation is completed for x of 3 minus n. The next operation is time reversal. That can be done with the help of this signal. So time reversal time reversal of x of n plus 3 will gives x of 3 minus n, right? So already I have performed x of n, or I have performed x of minus n with the help of x of n, right? X of minus n is the reversal of x of n. Similarly, I am going to perform I have x of n plus 3. So time reversal means I am going to get x of 3 minus n with the help of x of n plus 3. I am going to reverse this corresponding signal to get x of 3 minus n, right? So 3 minus n means I am going to reverse the corresponding samples by keeping the 0th sample as the center, and just I am going to reverse this corresponding sample, right? So the right side sample will be moved to left side, and the left side sample will be moved to right side, keeping this 0 as the center. It can be performed, look at here, now keeping 0 as center here, 0. Next, the sample starts from plus 1, so minus 1. When I shift, it will become minus 1. Then 1, 2, 1, 2, 3, 4, 5. So totally 5 samples on left side. Then when shifting, I will get same 5 samples on right side with plus values 1, 2, 3, 4, 5, etc., etc., right? So now this corresponding 1 will become minus 1, and its magnitude will be same 1, and for 0 it is 1, and for 0 it is 1. Then for 1 minus 1 it is 2 here, so for plus 1 it will be 2, and for minus 2 it is 0, 0, and for 3 it is plus 3, 3, and 4, 5, and 4 it is minus 1, and for 5 minus 5 it is 1, right? So this is the signal x of 3 minus n, right? So these are all the operations done on the discrete signal. We have one more operation, that is compression operation. We will see that in next video with the same x of n values. Thank you.